So today we're going to do our other trig angle formulas. We're called the double angle and half angle formulas. Again, you do not have to memorize any of these formulas. You'll see they will all be given to you. So the first one is the double angle for sine, or sine of 2 theta. We remember that 2 theta can really just be written as theta plus theta. So if we put that into the sum formula from yesterday, it would be sine theta cos theta plus cos theta sine theta. And we recognize that those are like terms, right? Sine cos, cosine. So it's the same thing as basically having 2 sine cos. So that kind of proves, if you will, that formula. The cos of 2 theta, if I squeeze that in up here, this would be the same as the cos of theta plus theta, or cos theta minus sine theta. So cos times cos, of course, is cos squared, sine times sine, sine squared. And then we have little spin-offs that are related to our original spin-offs, right? So we can write cos squared, for example, as 1 minus sine squared. And if you replace cos squared with 1 minus sine squared, 1 minus sine squared minus sine squared is 1 minus 2 sine squared. Or you could replace sine squared with cos squared. How can I replace sine squared? Let me think. I always get confused here. Sine squared plus cos squared equals 1. So if I move that over, so sine squared could be replaced with 1 minus cos squared, right? And then if I distribute that negative, right, I would distribute the negative 1 becomes this negative 1. That becomes a positive cos squared plus cos squared is 2 cos squared. But again, we'll write those all down for you, even the spin-offs. Okay, guess I meant to do this down here. So this would be sine theta cos theta plus cos theta sine theta. Just doing it again, which we recognize that those are like terms, so 2 sine theta cos theta. Cos theta plus theta would be cos cos minus sine sine. Cos times cos is cos squared theta, and sine times sine is sine squared theta. You actually don't have to really ever derive those. We're just showing you that those are true. Now, these we use a little bit of a different kind of formula. Use the double angle formulas to find the exact value of sine 2x and cos 2x. First, we give you our secret code for the quadrant. This is between 90 and 180, so aka the second quadrant. So I'm going to draw a triangle here in the second quadrant. Here's my angle x. Actually, this is my angle x, right? This is the reference angle where the sine is 3/5. And then I know from, of course, Pythagorean theorem that would be -4. We're going to make it a -4 since I went left on the x-axis. And then I'm just going to use my formula. The sine of 2x is equal to 2 sine cos. 2 times sine times cos. So it's 2 times the sine of that angle is 3/5. And the cos of this angle is ca, -4/5. And if I multiply those together, I get -24/25. If I do the next one for cos of 2x is cos squared minus sine squared. So the cos we said was -4/5 squared minus sine squared is 3/5 squared. So I have 16/25 minus 9/25, which is 7/25. So I'm basically drawing the triangle and then plugging in the formula. Here, my secret code is telling me between 180 and 270, so that I'm in the third quadrant. So I'm going to draw a triangle here in the third quadrant. The cotan, so it actually brings me back to cho, sha, ko, right? Cotan is adjacent over opposite. So this would be 4 and 3, but because I'm in the third quadrant, we're thinking of them as -4 and -3. Hypotenuse is always positive. From Pythagorean theorem is 5. And then I'm going to go through the formulas again. Sine of 2x is 2 sine cos. So 2 times the sine of that angle would be -3/5. The cos of that angle, -4/5. When I multiply those all together, again, I'm going to get 24/25. This time is positive. If I want to do the cos of 2x is cos squared minus sine squared. The cos of that angle is -4/5 squared. The sine of that angle is -3/5 squared, minus in the middle. So I'm going to get 16/25 minus 9/25. So again, 7/25. So a little bit of a different kind of problem for there. Then for the next part here, let's scroll it up. This doesn't want me to scroll it up. Let's see. There we go. Half angle formulas. And by this time, we're just like, oh, okay, whatever. Like, look at all these formulas. They look crazy. And the one thing you notice right off the bat is this plus or minus in each one. And so the main thing we want to know about that is plus or minus is decided by the original angle. So we look at basically what they're asking me for and what quadrant it's in, and that's going to tell me if it's a positive or a negative. So for example, sine of 22.5, I look at 22.5, that's in the first quadrant. I know sine is positive in the first quadrant, so I know that answer is going to be positive. To do the problem, I think of 22.5 as being 45/2. So my theta is 45, but I'm still finding the sine of a 22.5 degree angle. Since 22.5 is in the first quadrant, it's positive. This is 1 minus cos 45 all over 2. Well, the cos of a 45 is √2/2 over 2. And now we remember back to complex fractions where I would multiply each fraction by the LCD, which is 2. So when I do that, I'm going to get the positive square root of 2 minus √2 over 4. And the square root of 4 is 2. You don't have to write positive there. You could write it or not. It's understood to be positive. And that's how we would leave our final answer. Similarly, if we do cos of 22.5, cosine is positive in the first quadrant. So I'm going to take the positive of this. Well, actually, let me rewrite it. It's going to be the cos of 45/2. So my theta is 45, 1 plus cos 45 all over 2. Again, the positive is understood. The cos of 45 is √2/2 over 2. I'm going to multiply each thing here by 2. So I get square root of 2 plus √2 all over 4. But the square root of 4 is 2 over 2. There we go. Last one's here on the bottom, proving each identity. So I'm going to basically like use my formulas, right, to just plug in and see what I get. Again, it doesn't like me scrolling up, so I'm going to just try and squeeze it in here. Sine 2x. So sine 2x was 2 sine cos, and sometimes I drop off the x. And then cos 2x was cos squared minus sine squared, right? Well, I see this 1 here minus sine squared, and I recognize that 1 minus sine squared is the same thing as cos squared. So I'm going to substitute that, and then everything else here will stay the same, 2 sine cos. Well, what's cos squared plus cos squared? Isn't that just 2 cos squared? And now I bet you can see it. We're going to cancel out the 2's. We're going to cancel out a cos, and we're left with sine over cos, which is tan. And then I'll throw the x back on. So it's back to proving identities, taking one side of the equation, manipulating it to match the other. Here, I'm kind of scared here for a second. Let me think. cotan plus tan is 2 cosecant 2 theta. I might work with each side of the equation here. If I look at the right, this is 2 times 1 over sine of 2 alpha, or 2 times 1 over 2 sine cos. And those 2's would cancel. I didn't mean to write that, it's not a squared. So then this would be 1 over sine cos. I'm just going to leave that there. So that's the right-hand side of the equation. If I switch colors and I go back to the left-hand side of the equation, this would be cos over sine plus sine over cos. We've seen this before, right? We need to get a common denominator. So here we need a cos, here we need a sine. So you can see in the numerator, cos squared plus sine squared. Well, we know that that's 1. And then the denominator would be cos plus sine. And I normally would have written that. I'm just a little out of room here on the paper. And then I can show, like, yes, those are the same. And that is it.